Now, this is potentially a common situation or a situation you might run into where you might institute class-based shaping. We have a bottleneck to the local interface to manage congestion and prevent that uncontrolled drops in the WAN, right? We don't really want to drop stuff in the WAN. So we're going to manage it in the local area network. So this is going to divide the bandwidth among the various classes. And we're going to use this to map packets from software interfaces, okay? And so looking at this, we're seeing that the shape is 384 kilobits per second. And we have these different classes. We have subclass X, Y, and Z. And we're giving 50%, I'm thinking that might be mission critical traffic, and then 20% to subclass Y and then 10% to Z. How would we do this? Again, using MQC. Well, we'd set up a child policy and a parent policy map in this situation. The child policy map would indicate our different subclasses and distribute the bandwidth, the 50%, the 20%, and the 10%. Then we go into our shape all, which is the parent policy map, and we say we want to shape, again, to kilobits per second, to 384,000 kilobits per second, and we're going to apply this policy that then says 50% goes to subclass X, 20% to Y, 10% to Z. Then we apply it to the interface. Now, something about these percentages. Does it reserve 50% and say, tough, even though that particular class might not have any traffic right then and there? No, it doesn't. It's actually very friendly to the other classes of traffic, is the way to put it. And so what will happen is if I have that much traffic to send, then I obviously will use my 50%. Let's say that it's that subclass X that needs more. It's like I got subclass Y and Z, you're just kind of sitting there. They got nothing. There's nothing in their queues. Subclass X, though, getting hammered. You know, we're at 50% and then some. So what happens is subclass Y and Z, while they don't need their 20 and 10%, they will allow subclass X a little bit of their wiggle room. So in other words, they will allow that subclass X to go above 50%. Now, if they start getting traffic, wait a minute. Yeah, I was kind to you and I gave you some, but I need it back now because now I'm starting to fill up and I need that 10% or 20%, whichever subclass is being utilized. So it's not a strict, I have 50% and I am not giving that up. If I'm not using it, I will share. Same thing with the 20% and the 10%. So those classes will be very harmonious to each other, I guess is the word, and they will work together to ensure that there is fair amounts of bandwidth for everybody so that the data and everything else can get through.